All right, guys, this is a review of our test from last week that we are retesting this Thursday. So I just want to go over it so you can guys have an understanding of how to work those problems up, okay? So question 1 is, what is the solution set of a quadratic inequality? So again, we're going to take this and we're going to graph it, okay? So we're going to go to Desmos, which I already opened. All right, and we are going to graph it. I put this equation in exactly the way it says in the question. And what popped up here, okay, as you can guys see, are shadings on each side on the outside. Now, you're only going to have two options. It's either going to be shading on the inside, which normally you would have in here in the middle, or you're going to have shading on the outside. Well, this inequality gives us a shading on the outside, and the 2 points are -3 and 4, okay? I'm going to graph it just to help myself. Again, you can solve it by hand, but you can also graph it just to help yourself. So I'm going to graph it. So we said that the point right here, let me see, the point right here was at -3 and 4, okay? And we also know that the shading was on this side right here, okay? So I already know that C or D, it's not going to happen, okay? So, because this represents the inside from point to point, okay? Now, all right, so neither of these can happen because, again, you guys have between the points. But what we are doing, it's either A or B, okay? So we are coming from -infinity, and we are going toward positive infinity. So our area is right here. So it's going to be a -infinity less than, not equal to, okay? Because we cannot put an equal sign on an infinity. We don't know what infinity is. Okay, x, and then less or equal to -3. So that's our first point. Then the second point starts from 4, so it's going to be 4 less or equal to x, okay, less than infinity, okay? So again, all we have to do is check those points here and make sure that we stop at the right points. And all right, now, if I would want to solve it algebraically, right, if you need to show work, so again, back it up with your Desmos. So go back to Desmos and look at what it gives you to make sure you check your answer. But if I would want to solve it algebraically, okay, again, I would have used A times C method to multiply and solve quadratic equation. I will have -12, and it would have to equal to -1. Now, I already know, looking at Desmos, that the two factors are 3 and 4, okay? Now, 4 has to be negative, so it's going to be x plus 3, x minus 4. These are my two factors. Now, when I equal them to 0, they're going to give me x equals -3 and 4, okay? Again, this matches what we talked about and what we saw in Desmos. Now I'm going to make that number line. As you remember, I put negative, excuse me, sorry about that, and then 4 right here, okay? Okay. Now, again, I'm going to pick different numbers that are in between -3 and 4, which is 0. I can pick -4, which is more greater than -3, and 5, which is greater than 4. And I'm going to pick one of them to check. So I'm going to pick 0. I always pick 0 because 0 to me is the easiest, okay? If I pick 0, that's 0 squared minus 0 minus 12 is greater or equal to 0. Again, zeros will disappear. I get -12 is greater or equal to 0. That lets me know this is not a true statement, so this is false. If this is false in the middle, then there is no other way but this to be true, okay? It has to be, because you're either going to have two shadings on each end, or you're going to have the middle shading, okay? So again, we go back to answer B if you want to prove your answer. All right. Number 2, it says a roll-up t-shirt is launched for the t-shirt cannon during halftime in a football game. It is launched upwards from the height of the 5 feet and initial velocity of 56 feet per second. Here's your equation. You are going to graph it in Desmos. Okay, you're going to write this equation with an X, not a T, because Desmos does not read a T. I'm going to put an X instead and a 5. Now, what is the inequality here? It says, write a solved inequality to determine when the t-shirt is above 40 feet. What does the word above mean? It means more, okay? More than 40, okay? We're going to take this and we're going to, again, plug it into Desmos. So let me look right here. I already have it ready for you. What is it going to look like? Again, I took this equation and plugged it in. this is supposed to have a 40, okay, in here. So again, 40. So what are my points? Now it is shaded on the inside. My points out 0.815 and 2.685. So when I'm writing my inequality here, I know it's in between the points. So 0.815 less than x less than the other point, which is 2.685. 2.685. Okay, so again, it is shaded in the middle. So you do not have an infinity signs. You are in between the points. Okay, so this point is less than x is less than this point. Okay. All right, so here it says solve the following quadratic equation by factoring. Again, you have to show work, but follow Desmos to check your work. So first, I like to graph it to look at it, okay, to see what my answer possibly is. If I graphed it, this is my answer, okay, this is the equation. My two intercepts, my two solutions are -2 and -0.4. -0.4 is -2 divided by 5, okay? So I know that my answer should be A. Now let me prove that algebraically. I do not like big numbers. So I don't want to multiply 10 times 8, which is 80, and find factors for 24. So I'm going to look for greater common factor. So I know I can divide each of these by 2. Okay, so I'm going to take the 2 out, and I get 5x squared plus 12x plus 8, plus 4. Okay. Now, 2 is my greater common factor. It does not matter. So 2 does not matter anymore when we equal it to 0, 1 won't mean anything. So what I'm concentrating is what's on the inside. So I'm going to use A times C method and find 2 factors and multiply to 20. 5 times 4 is 20 and add to 12, which is 2 and 10. So 2 carries down, and I show you what is going to happen to 2. And then I'm going to have the 2 factors, x plus 2 and x plus 10. Now, if I would have made a mistake, I would equal it to 0 and think that my answers are -2 and -10. Now, because I forgot something, but because I checked it on Desmos, even if I got to the point, I'm like, okay, I made a mistake. Okay, that's not the correct answer. The correct answer should be A. Again, use Desmos to guide you to the right direction when you get lost. So I know this is not proper. I know that that's not the answer. I do know it's a fraction, which means I'm dividing it by something. Okay, well, let me look back. What more am I forgetting? I'm forgetting 5 is my leading coefficient. So I need to divide both of them by 5. Okay, now, if I equal each of these terms to 0, okay, I'm going to get the correct answer, exactly what it's supposed to be. 2 will never be 0, so that's not a true statement. Okay, x will equal -2 over 5. I moved the 2 over 5 to the other side, and x will equal -2 as well, which is, in fact, answer A. All right, here, solve the equation. Again, solve means you move everything to the other side. I'm going to move 32 to the other side by subtracting it. I'm going to have 8x squared equals -32. Remember to divide it by 8. After I divide it by 8, I get x squared equals -4. Now, very important to get rid of this radical, that square, I'm going to square root it, okay? When I square root it, I see right here, this is a negative. That means that's an I. So my answer will have a 2i, okay? Because I'm square rooting the 4, and the I comes out as a negative. Now, it has to have a plus or minus sign. Please do not forget that. This is very important. Points are taking off if you're forgetting that there's 2 possible answers when you're square rooting anything. All right, solve the equation. Again, I'm looking at this answer and I'm saying, well, it looks like I have a square root. It looks like I got an I. There is a possibility that I have to use a quadratic equation to get those answers, okay? Again, I can graph it to see where am I going with it. So I'm going to show you. I can graph this equation, which is right here, and I can tell, is this the one that we're doing? Let me see. Yes. And I can tell you right here, this one, it's not an imaginary function because it crosses x-axis. It has decimals. So you're getting the decimals, so I can possibly eliminate some answers, okay? I can eliminate the answer with an I because I know this is not an imaginary solution. Okay, so A and D, it's a no-no. Now, I could possibly put this in a calculator and figure out what is -5 plus root 21 and what is -5 minus root 21 and figure out what is my answer. But again, if I have to prove my work, then I would have to solve it. So to prove my work, I know that A and B definitely it's not it. I'm eliminating it. So what I'm going to do is I'm going to use a quadratic equation and plug it in. So I got -b plus or minus square root of b squared minus 4 times a times c divided by 2. So now let me use this quadratic equation to plug in those answers. So I got an a, which is 1, b, which is 10, and c, which is 4. So let me plug it in. So I got x equals -b, which is -10, plus or minus square root of 10 squared minus 4 times 1 times 4. Okay, all divided by 2 times 1. Okay, so on the inside, just right here, if I put this in without the radical, I'm going to get 84. So it's going to be plus or minus square root of 84 divided by 2. When I take the root of that, okay, this is going to be -10 plus or minus 2 root 21 positive over 2. And then all I have to do is divide each of these by 2. So that's going to be -5, that's going to be 1, and that's going to be 1. Why? Because 2 is divisible in all three terms, and it has to be divisible in all three terms. So the simplified version is going to be -5 plus or minus root 21, which would have been answer B. And then again, I can put that in a calculator and check, does it match the decimals right here, -9.583 and -0.417. Okay. All right. Moving on to the next one. This one, I do not need to go over this one. This one is correct. So everything she did was a correct statement. If I want to eliminate, it says answer E. In step 2, Emma did not use the correct values for A, B, C, or D. Well, she did. Okay, she subtracted the 3, which was correct, and then A was 3, B was -4, and C was 6, and so on. Step 4, Emma should not have gotten an imaginary number when simplified. That's not true. 60 minus 72 is negative value. And then C in step 5, Emma did not simplify the 14 underneath the radical. That is correct. You do not touch the radical, okay, ever. All right. This one over here, we had this question a couple times for you guys, so we continue to make mistakes. Now, you can try to go the longer route where you take each of these values and you plug it in instead of this C, and then check every one of them. But when you do that, please make sure that you do distribute the negative after you plug in this number. But I would not recommend it. Again, that's your backup plan if you don't know what you're doing, and that's okay if that's what gets you an answer. It's a different strategy. Now, what I will do is make sure that I distribute the negative first before I do anything else. So -8 minus 7i minus 3 minus ci, okay, equals -11 minus 12i. Now I'm going to use only the I parts because that's all really I'm solving for. I'm only going to use the I parts to set it equal to each other. So I get -7i minus ci equals -12i. Now, of course, I'm just simply solving for C or A or X or whatever that is. I'm going to add 7i, cancel. -ci will equal -5i. I'm going to divide both sides by -1. Okay, so ci will equal 5i. And of course, I proportionally on each side of the equal sign will drop. So C will equal 5, and that is your answer. Okay, again, you can take that and do exactly the same thing. And again, if you want to use the other route and plug it in, I would recommend it, absolutely. So if you need to write this down, pause the video, I'm going to erase it. Now, if you do want to plug in each answer and get an answer that way, that is perfectly fine, but make sure you're plugging it into the original equation before you distribute the negative. Okay, otherwise you're going to mess yourself up and it's not going to give you the correct answer. So I'll just give you an example for, let's just say D. Okay, so if I'm only going to plug in -8, I'm going to do exactly what it is originally, put it in the parentheses, and then minus 8i equals -11 minus 12i. Now, after I plugged in the original, I'm going to distribute the negative to both, okay? So this is going to change the equation to -8 minus 7i minus 3, now plus 8i, okay? Now, -7i plus 8i is not going to give me -12i, okay? That's just another strategy. All right, for next question, again, to simplify this expression, you're going to distribute the 4 and you're going to distribute the negative to both steps. This is going to be -12i plus 5. Now the negative will change the 6 to a negative and a 2 to a positive, okay? After that, you're going to combine like terms. So -12i plus 2i, it's -10i. And you're going to combine the numbers, the real numbers itself, which is going to give you -1, okay? All right, this is a conjugate of the binomial. So I know for a fact before I even solve it that when you multiply one parenthesis by their conjugate, okay, I am going to end up with a real number. Okay, so I know A and B are not going to be true. I also know that the number is going to be a larger number because I'm going to add it at the end, okay? And here is why. You're multiplying two binomials and one of them is a conjugate, okay? The only thing that's different between them are these numbers. Here is a plus and here is a minus. So naturally, when you multiply them out, one is going to have a positive 18 and the second 18 is going to be -18. Okay, it has to be a -18i because again, you're multiplying one with positive, one with negative. Now, the number in the last box is going to be a -9i squared. Very important to notice it is going to be a negative at all times because you're always going to multiply two opposite i's, right? So the conjugate is the opposite sign of the one that you're given. So it's always going to be negative. Now, these are going to equal to a 0 because -18 plus 18 will give you 0. Now, what you have left is 36 minus 9i squared. Since this will always be negative, because you're always multiplying negative times positive, and this will always be replaced, the I square gets replaced with -1, this number will always end up being a plus. It's just always going to happen. So this is always going to be a larger number, which is 45, okay? But again, you can estimate that by using testing strategies. All right, number 10, again, this is -2i raised to a 92. So remember, 0, 0, which is no decimals, indicates I to a 0 power, which is 1. 0.25 indicates I to a first quarter, which is I itself. Okay, 0.5, which means that's 2 quarters. That's -1. And 0.75 indicates that's 3 quarters, and that indicates -I. Now, I take and divide this 92 by 4 because I'm trying to replace I to a 92 to a smaller value that I know I can solve. So 92 divided by 4 is 23, okay? That says nothing there. Nothing there means 0, 0, okay? There is not 25, there is not 0.5, there's not 0.75. So I am taking this I to a 92 now, and I'm replacing it simply with I to the 0. You are taking the bigger exponent and making it smaller to something that you know the value of and you can solve, okay? Now, I know I to the 0 is 1, so I can replace this I by a by a number 1. So I'm not keeping the I there anymore. I to a 0 is 1, okay? The value of I to a 0 is 1. And of course, I'm keeping the -2, and then I'm going to multiply them out to this -2. All right, so again, very important, the I goes away, okay? Why I goes away? Because I to a 0 power, and instead of I to a 92 power, the value of it is 1, okay? All right, this one, again, very simple. You have a -49 radical, okay? Minus 5. Very important, negative underneath the radical indicates I. So I can do and rewrite that as regular radical 49i minus 5 now. I know that a square root of 49, it's 7i. Don't forget plus or minus. A lot of points were taking off because you guys forgot plus and minus. There's two possible answers. Minus 5. Again, it has to be in a standard form, so a real number comes first, plus or minus 7i comes the imaginary. So you got to make sure it's in a standard form, and you got to make sure that you're using plus or minus for a radical. Now, this question right here, again, you are looking for solutions to a system of equations. It's almost like, you know, two people running into each other on the hallway, okay? Where do they cross? Where do two functions cross, okay? Again, this is not where the x-axis is. This is where two functions cross each other. So in this point, this is -2, -1. And in this point, you got 1 and 2, okay? Point comes in a parentheses. So when you're writing it, please make sure you put it in a correct form, okay? And it cannot be in a brackets. That's an integral, okay? It cannot be just numbers written freely as just 1 and 2. That's just 1 and 2, okay? So it has to be in the parentheses. Answered correctly, please. All right. This one's to solve the system of equations. Again, you can equal them to each other and solve them that way, okay? Or you can just graph them, all right? So I have graphed it. You can read it off the graph. It will be, let me see, right here. I have put them on here, okay? Now, again, what is my answer to system solving system of equations? It's where they cross, okay? So right here where they cross, if you can't see it, oopsie, make it bigger. Let me close this and put it up. If you can't see where they cross, they only cross in one place. Sometimes they cross in two, just like the other equation. Again, they cross in point 1 and 9. Please make sure that you guys repeat it in the parentheses as a point, okay? So this is your x value and this is your y value, okay? 1, 9. All right, here it says select functions, all that apply, functions that are imaginary. So again, you have to show work, so you have to solve it, but you can give a heads up and check it on Desmos. So I did that. I went back to Desmos right here and I plugged them all in, okay? Well, let me see. How do I know that a function is imaginary? I know that a function is imaginary when it does not cross x-axis. So the first function is a real function, okay? It's not imaginary. It will have real solutions. So because it does cross x-axis, okay? So this one, it's real solutions, okay? Second function, if I go back to it, let me uncolor it. Okay, it does not cross x-axis. It hangs above, okay? It will never cross x-axis. That tells me this function is imaginary, okay? So it just helps me kind of narrow it down. I'm still going to have to, so this, it's imaginary, okay? I'm still going to have to, sorry about that. It's still going to have to solve it. All right, so this second function right here, all right, so again, on this function, I know this is imaginary. The next function, if I look at it, okay, if I undo this and I put this one in, this has a real solutions. It's crossing x-axis in 2 points right here. So again, that's not an imaginary function. So this is a no-no. And then, so for this one, for the last one, let me go back here again. If I unplug it, look, it looks above, it does not cross x-axis, so that means it's an imaginary function. Now, how do I prove that? Well, you equal them all to 0. So if you equal x squared minus 30 to 0, I'm going to add 30 to both sides to solve for x, okay? X squared will equal 30. Now you got to square root both sides to get rid of it. Right there, it tells me that it's going to be a real solution. There is no negative and there is no I. So that means x will equal plus or minus root 30, okay? Because root 30 does not simplify, okay? Now, imaginary, b. Let me do b. So b is x minus 3 squared plus 5. I know that you guys want to multiply this out in a box method, but you don't have to. We did that a couple weeks ago where you can simply move the 5 to separate the parentheses and the square. okay, to be by itself. Now 5, it's on the other side. Now to get rid of the square, again, I can square root both sides. Boom, this won't cancel the square. This tells me it's a negative. Negative means I underneath the radical. So I get x minus 3 equals I root 5, okay, plus or minus, and then all I have to do is move the 3, okay? So again, for this one, x will equal 3 plus or minus I root 5. Okay, so right there, this is an imaginary, okay, which will have imaginary solutions, all right? All right, now C, you would have to do a quadratic equation because you cannot find two factors that multiply to negative 10 and add to 4. So you will put it on the quadratic equation. You will get negative b, which is negative 4 plus or minus square root of 4 squared minus 4 times 1 times negative 1 times negative 10 divided by 2 times 1, which is 2. Okay, underneath the radical right here, you're going to get 16, 40, so 56. So right there, plus or minus over 2, square root of 56 is 2 root 14. So we're going to get negative 4 plus or minus 2 root 14 over 2. We're going to divide all of it by 2, okay? Which means we are going to get this by 2, this by 2, and this by 2. So we're going to get negative 2 plus or minus root 14. This is a real solution, okay? 2 of them. All right? And then the last one, again, if you need to pause it to write it down, please do so. And then the last one, I'm going to delete this side right here. It is x squared plus 12. That's supposed to be imaginary according to Desmos, so let's check. I get x squared plus 12 equals 0. That will move the 12 to both sides. X squared will equal negative 12. Now, when I want to square root it, look what happens. X will equal plus or minus I to root 3. Okay, so again, this is going to be imaginary because it has a negative underneath the radical, okay? So I was correct, and the Desmos, that these are my two answers that are correct. All right, this is a discriminant. That's b squared minus 4 times a times c. You guys have a, b, c, okay? So that's 6 squared minus 4 times 7 times 2, all right? So that's going to be negative 20. So this is your discriminant. Now, what does this discriminant mean? It's asking you to determine the number and the type of solution. Remember, negative discriminant, it's what you put underneath the radical. So when we have a quadratic equation, you get negative b plus or minus. The discriminant goes right here, okay? What does that mean? That means that this is negative, which means this is going to indicate I, which is imaginary. So I know the negative discriminant indicates imaginary solutions, okay? And there's 2 of them, all right? If this number would be positive, you would have 2 real solutions. And if this number would have ended up being 0, this is just an extra example. If you end up this being 0 right here, okay, that would mean 1 real solution. This is where function touches a graph at the x-axis at one point. But these, the answer to it, it's negative 20, and it is that's a discriminant, it's negative 20, and it is 2 imaginary solutions, okay? Again, the number of solutions and the type. All right, this is a regression question. We would go to Desmos to plug this one in for sure. All right, so in Desmos right here, I would press this button and do table, and then you will enter the table. I already did it here for you, okay? So I entered what was given. Now you would go right here into the line, and you would press Y1. Why do I press Y1? I press Y1 because right here, my table, okay, is Y1, and I'm trying to refer it to this table. So remember, because I can't write on it, remember that a standard formula, it's y equals ax squared plus bx plus c. We only adding the 1 here because we're referring it to the table given to us right here, okay? The table of y1 and x1. That's why we're using the 1 for it, okay? It's very important. So that's why we have a y1 here. We are going to use the left corner wiggle up here, left top corner of your keyboard. There's a wiggle. And then we're just going to use the formula. Normally we would say ax squared, but in this case we're going to put a 1 there, and it automatically does it for you. Why do we put a 1 there? Because again, we're referring to right here to this x1. Okay, so we're going to put a 1 there. Then we're going to add bx, okay, 1 again, and then we're going to add c. That's just a normal standard formula for quadratic equation. Now, these are all the numbers that we given right here, okay? These are the numbers that we given. That's your A, that's your B, and that's your C. So we are going to use it, and we are going to put it into a full equation. So when it's asking you to put a full equation in here, and instead of this A, okay, and B and C, this is where I'm putting those numbers that I just got from Desmos, okay? The numbers were, and it also says round it to the nearest hundredth. Make sure that you got 2 places past the decimal, okay? So that's 2.14 x squared, plus my b was 0.94x, and my c was 21.8, okay? So that is the equation that we were looking for. Now, it says in part B, use quadratic regression equation to predict the number of rabbits in 7th year. So I would have put 7 into here. Oopsie, change the color. So I would have put 7 into here instead of the x, okay? I'll use 7 and plug it in instead of the x, and then 7 as well here. And I will put it all into the calculator, and then I would get my answer, okay? And again, when you put it in, the answer is B, okay? That would be a predict answer. It would be 1.33.24, and we round it up, okay? And then the last one, you're just matching which one matches -4 plus 32i. So in the first example A, you're going to have to distribute. So I get -6, okay, plus 44i, -2 now plus 12i, because those are going to change. Now I can already tell that 44i plus 12i will not give me 32i. So A, it's not correct, okay? All right, B, I am distributing the I to both. So this is going to be 4i squared plus 32i. Well, it kind of looks familiar, but now we're going to replace the I squared with a -1. So now this is going to become a -4 plus 32i, which does match our answer, okay? C is simply a box method. So we're multiplying -2 minus 4i times 6, -6, and then minus 4i. So again, let me see if I can kind of get an idea if that's going to be true or not. So this is going to be 24i. This is going to be 8i. And then this is going to be 16i. Now, this will match 32i squared. But 12, let me see. 12 plus 32i plus 16i squared. Now we're going to replace the I squared with a -1 again. So this is going to be -16. 12 plus 32i. And in fact, it is 12 minus 16 is -4 plus 32i. So again, this is also a correct answer. Now, if you need to pause it, pause the video. I'm going to erase it. Okay. Now, D, let me do D. So D, it does not mean you distribute the 2. No, it does not. It means there's 2 of those. Okay, so that means you also have to do a box method and multiply this twice. Okay, so -2 and then plus 16i. So -2 times -2 is 4. -2 times 16 is -32i. And then this is going to be -32i. And this is going to be positive 256i squared. So right there, I don't even need to continue. I know if I combine these two, that's going to give me a negative 64i, and that's not what I'm looking for, okay? So this is a no. And then lastly, okay, let's do the last one. Last one is very important. Again, you have negative square root of 16 here plus parentheses square root of negative 64 times 4. You will never, ever, ever multiply 64 times 4, okay? You have to get rid of the radical first or simplify the radical before you can do anything, okay? So I am going to understand that there is a negative there, which means I. So I can do 64i times 4, which really is going to end up being 8i, okay? Because the square root of 64 is 8i. So I'm going to erase that and replace it with 8i. That's still in the parentheses, and then negative 16 root, okay? Now, can I multiply these two together? Yes, I can. This is not addition, this is a multiplication. So I can multiply 8i times 4, okay, which is 32i. And then there is plus negative radical 16. The negative is on the outside. So it does not belong as an underneath the radical. It does not belong as an I. It's simply a negative 4 plus. Now, if you're not sure how, if you don't remember, if you get confused between I or not, put this in a calculator and see if you get an actual number as negative 4. Exactly the way it is. Or if you would have had negative 16 like this, it will give you an error, okay? So when it gives you an error, you got to remember the reason it gives you an error is because there is no such thing as a radical of a negative number. That's when your imaginary numbers come. But if it does calculate for you, that means it's not an I, okay?